let's get started with the webinar today. Today's webinar is on 2D interactive technical illustrations. If you should be experiencing any problems during the webinar, please use the chat window to communicate with us. All attendees will be muted for the duration of the webinar. There are some associated materials that are available for download via the chat panel. So we invite you to download those. It's product information. And so we invite you to access that information. Please post your questions at any time during the webinar. So feel free, whatever anything comes into your mind, please post it. And then that way we can answer those questions at the end of the webinar. And if we don't get all the questions done, we'll have we can follow up by email. For those of you not familiar with Larson Software Technology, we're based in Houston, Texas. We're actually founded in 1984 as graphics technology experts. We've been doing that for over 30 years. We first promoted the CGM usage by providing a free CGM viewer. We're a member of the CGM Open Foundation, where the CGM standard is maintained. At Larson Software, we develop powerful 2D and 3D technical illustrations, conversions, and viewing solutions, all based on open and industry standard file formats. We're the developer of the first HTML5 CGM viewer that allowed CGMs to be viewed on any platform in any browser. We also introduced the first SVG profile called Tech SVG to assist with the standardization of the file format and make it more practical to use in the aerospace industry. Our products are also now support the new SVG S1000D profile. So with that all said, let's get started with the main part of our presentation. And I'll turn it over to Dave Manick, who will be doing the main part of our presentation. Thank you.
Yeah, excuse me. Yeah, thank you, Don. Good day. Thanks for joining us today. So this is kind of the main part of the presentation. So we're just going to try and go through a few slides just to kind of familiarize yourself with what we're talking about with interactions, with like hotspots and so forth. Then we'll have some demos to show you how that can be achieved using our VisX Edit products. And then at the end, we'll just summarize and take any questions that you have. So when creating interactive illustrations, you really would be using two possible file formats, CGM and SVG. So computer graphics metafile and scalable vector graphic. The two formats contain both metadata. So in other words, they can contain this hotspot information, which will allow us to make it interactive. The addition of metadata really provides the option to you to link illustrations to text. So if you've got an interactive electronic technical manual, then you could link the illustration via a hotspot to the text. So probably the most familiar thing might be an illustrated parts catalog, where you select a part on the parts list and then you might order that part. And so today we'll demonstrate how you do this by adding metadata hotspots both manually and automatically. We'll conclude by demonstrating interactivity in a real S1000D IETM. So this diagram really just shows you the workflow. We'll be going through some of these things today. The first demo, we'll be looking at how you convert 3D CAD data to create a new illustration, then add interactivity to it along with annotations, and then how we then go through that into the export as CGM and SVG, go into your CSDB, and then finally build your IETM, where you would view the CGMs and SVG, interactive CGMs and SVGs. So that would be in the viewing environment, which will be embedded in the IETM. We could also go down another route where it's a legacy illustration that hasn't been hotspotted. So things that you've done previously, which you now want to move over and create interactivity for them. So the route is similar, but this time, obviously, you've already generated the illustration. It could already have call outs. So that would change the dynamic really to add the interactivity to it. So let's look at the two formats to begin with. You're probably all very familiar with both of them. We have this slide that we created for CGM and SVG. What are the differences really? And one of the biggest differences is CGM's been around a very long time. And so there's a big archive of files that are already out there that you can be using. You could convert them to SVG, but you're probably just better off staying as you are and not having the risk of losing information in a conversion process. So the biggest difference, I think, between the two really is that SVG was not really designed as a data exchange file format, and that's probably its biggest kind of gap that's missing, and it probably will not change. So we'd always advise people to, if they have CGMs already, keep them, convert to SVG, but keep your originals really in CGM. So let's look at CGM first. It really was the original graphics format in S1000D, and that was mainly because it was an open standard. So it wasn't owned by anybody, it wasn't proprietary, and that was really the driver for adopting the format. The other one was that in version 4 of CGM, hotspot information was allowed inside the file, which again was a big driver to adopt it for the S1000D community. CGM, it's a multi-purpose file format. It's capable of editing and displaying. So this could be your archive. So you can edit the file and display it as well. Whereas, as mentioned before, SVG, for display, it's absolutely brilliant, but perhaps not as a file you want to keep as your long-term file. So the CGM profile, this really guarantees interoperability, and you can validate these files as well. So CGM version 4, it contains something what we call application structures. This allows us to add hotspot information as metadata into the CGM file. The metadata can be contained inside the CGM or in an XML companion file. So the companion file, which is part of the S1000D specification, allows you to store information outside of the CGM file. So you really have two choices how you add hotspots to the illustration. As I said, XML companion file is defined in the S1000D specification. So what about scalable vector graphic, SVG? Very good format, younger than a CGM, but it was mainly designed to be used in a display format on the web. So vector graphics in a web browser without a plugin. So it has native support for all the popular web browsers like Chrome, Edge, Firefox, Safari. So everything really that you need is really within the file itself. So it's a native file, which is important in respect of no plugin required. You can still have interactivity, and the quality is very good on the screen as well. So the SVG specification, if you didn't know, SVG is basically an XML file. So being XML, obviously it's got a structure to it. It's an open format, which is attractive. There's SVG 1.1 and SVG 1.2. 1.2 is what they call the tiny version, which was really designed for mobile phones. We'll talk about it in a bit, but the S1000D spec, the SVG 1.1 profile was used for the specification itself. So just to reiterate, SVG, the benefits, it's native to HTML5. No plugin is required for display. It supports metadata, enabling interactivity. You can embed raster images in it as well, which CGM can. I didn't mention that for CGM. Has the ability to include 2D animation as well, but you would need a tool really to help you do that. And then, or an authoring software. And it can also be data driven from a spreadsheet or database. And this is really where XML is its strength, really, that you can do a lot more with it. So the hotspot definition is really defined in the profile. This should align to the current implementation of CGM naming conventions. The new SVG profile is based on, as I said, 1.1. So the spec, what it did really was try to align both the CGM and the SVG profile so they use the same application structure attribute. So we have some consistency. So S1000D issue 6 as the S1000D SVG profile. You'll see the chapter number there if you want to make a note. And so basically, we've now got a standard for both SVG and for CGM within the specifications. So the first thing we're going to look at is 3D to 2D, and that was on the workflow we showed earlier. So CAD for creating new illustrations now is very important. We need really to we don't need to repurpose data, or sorry, can repurpose data from our CAD systems and create 2D illustrations. The format we would use, or in our software, we're predominantly using is STEP. And believe it or not, STEP is part of the S1000D specification, but more as a data exchange format, not as a way to present data to the customer or in an IETM. So all major CAD systems should support STEP. So if you think of Creo, CATIA, Pro Engineer, if you still have the legacy systems, Team Center, all of these softwares will support STEP. So we should be able to get that data over. The one consideration you need to make really is if you're converting these files is large file sizes. So you really need to have a good computer to convert them, and they're definitely not suitable, as I said before, for publishing in an IETM. So let's go to the first demo. So we're going to convert some 3D data to 2D. So hopefully you can see the software on the screen there. This is Visx Edit 3D, and we can do an import, and we can import, as we just mentioned, a step file. So we have other options as well: IGS, IGS, step, VRML, GLTF, OBJ. But for best quality, we think step is your preferred format. If I go to the diff file here, differential, and I can bring in this particular model. It's not a big model, but it'll give us the idea. I can just bring that in and open it. So now we have the model through, we could begin to work with it. So if we're going to create a 2D illustration, say for a spare parts catalog, we want to separate all these parts from each other so we can annotate them. So I'm going to go to explosion first and create. Say OK. And now I'm going to start dragging these components apart. I do have an auto mode as well, but for the sake of this demo, I'm just going to drag these parts away manually. But we could also do this. We can automate this as well. So I can shift click, move that away. Let's just move this a bit further. And I can grab the case casing down here. I'm going to move this in this direction so we can see what's behind it. And then we can also move parts on the perpendicular. So on the center axis here, I can drag this away. And I can also drag away the gear wheel. Okay, so I'm going to save that. That is not gone away. I just need to manage. And then now I can export this out. So I have two options here. It's really CGM and SVG. So I'm going to do a CGM and put it on the desktop. Let's just rename it. Okay, so this is going to do a hidden line removal and create a 2D file for us. So I'm just going to leave the default settings here. It's now going to convert that file. So let me just quickly go back. And if I put it on the desktop, oh, it's here, sorry. So here's the converted file. So at this point now, I could still move these things around and reposition them, but you'll see that if I zoom in, let's zoom in on a particular part here. This is a really good quality in the respect of we've got arcs and we've got kind of ellipses. So we've got a really good quality illustration, which we shouldn't need to do too much to. And then we can annotate this up and put any other lines we need on there, location lines and so forth. So if I just quickly go to, I'm going to cover this a bit more in the next part of the demo. There you can add your call out, your hotspots. So the indicator here is red is the hotspot, and you can see on the left over at the top, this is where your first hotspot has gone. So we've gone from 3D to 2D, hotspotted the file, and I also have an option to now save this as a CGM again from here, or I could save as an SVG. So if I go to save as, you could also do an SVG file at issue 6. So if I just to save that, and that file has been created. So that's very quickly how you can get 3D to 2D with very good quality from your CAD system. Okay, let's go back to the slides. That was Visit's Edit 3D, and then 2D was when I was doing the annotations. So S1000D interactivity. This is the chapter number where you'll find a lot of this information. It's a pretty long one, so I'll let you just make a note of that, although we will be giving the slides out. So this is the actual chapter, and you'll see here relationship to CGM version 4 and relationship to SVG 1.1. So this will all be about the hotspots. So I recommend you go and investigate this particular part of the spec. So what do we need for interactivity to be enabled? So hotspot information, as we've mentioned earlier, can be included in potentially, in this case, 5 different file formats, but only 2 of them really are graphical, the SVG and the CGM. But you definitely need 2 for the links to work between the text and the graphics. So you'd have your data module or XML, and then you would have your, either a CGM file or an SVG file, either one. Then you can link between the 2. Optional is you don't have to have an XCF or companion file. It really depends on your use case if you would choose that. I know in the airline industry or in the aircraft manufacturing industry, they do use this quite a lot. And then the other option is what they call a metadata file or IMF. This is more it's kind of a richer format than XCF because you can contain information about the drawing or illustration, like for instance, security things and things like that. So it's a bit more akin to a data module than it is a graphic file. So those are the this is the information you're going to need. You need an XML data module. You need either a CGM or an SVG to contain the hotspot information. Optionally, you could have a companion file, an XCF file. And then you could also optionally have an AMF file. You probably, the IMF is just an enhanced version really of XCF. So you probably wouldn't use both of them. You'd use one or the other. So the IMF is probably worth investigating. The only downside I would say at the moment is the dependency on the support of third-party software like the CSDB and so forth. So what does this all look like in code? Is at the top left here we have the XML file, and you can see here this is our application structures. You can see the hotspot information, and here is the ID of the hotspot. So application structure ident, and then we have the name, the name of the structure. So if we go down now to look at the illustration, you can see the ID is hot001 and the name is 1. And that is contained in the XML and it's contained in the CGM. And therefore we can create that link between the two. The same would apply now to SVG. The same structure, the same outcome. You've got a link between text and graphics. So this is the XCF file. This is where the hotspot ID now is in the an XML file, a companion file. And the region is all the coordinates of where that hotspot is. You're wondering what all that code is. So that it's not something you would author, but within VisXedit, I'll show you how you create that just with a drop-down menu. So that was all done. And then finally the IMF, you can see the IMF has a lot more kind of information to it other than just the XCF. We've got the hotspot information here. They call it the ICN object. And then above that, we have a identification and status mode or status fields that you can fill in that are more akin to data modules. This is the IMF file. So this really would enable you to manage illustrations in a much more with granularity than just at the moment. So here we go back to the demo again. So I'm just going to bring up VisXedit. We looked at it briefly earlier on. That was the file we converted. So how do we add hotspots to this? So we can do this manually. So we can just select an area. So I can create a rectangular hotspot around the number 11 here. And I'll say OK. And that immediately becomes a hotspot. Just to do that again. So this will now be a sensitive area on the illustration. And if you look at the top left, these hotspots have been added in to the illustration here. The other option I have is to select, say, a shape, and you can turn that into a hotspot. So I can transform this object into a hotspot. And then we have just the ellipse, so you can see it fills that whole area. And we've added another hotspot to the table here. So manual is a way of adding hotspot manually, and we have the tools to do that. The next option would be a bit more productive. It would be to auto hotspot an illustration. Now this one is a bit different because it's obviously a flat view, but it's also got call outs, but this is raster. So this is not a vector file. It's all basically pixels, so it's been scanned in. So our hotspotter you can hotspot vector, but you could also via our technology, in this case, kind of an OCR technology, I can auto hotspot the whole thing. So I'm going to start this in a minute. If you just look on the left as I do it, you'll see all the hotspots that it creates. And I can set up all the parameters for this to get it as close to doing it as the the first time as possible. And you can see that it saved a lot of time there because it did it almost instantaneously. And then you've got all the hotspots here. You might see it highlighting on the other side. So that has all been now added to that file. Okay. So another way we could do this is more akin if you brought that CAD through and you haven't got any annotations on it, call outs. Here I can use what we call our call out tool. Let's just change that to 1. And it's here on the toolbar, add call out. So now as I click and drag, you can see that I'm creating the hotspot because this is the red area on the screen. Now it's in a rectangle there. You can have none. You don't have to have any surround the number. Let's just turn off the visible hotspot so you can see rectangle or circle. Whichever one is your house style, you can choose that. So now I'm going to do my second one. I'm going to settle on the circle. And it's going to do this incrementally up. And you can see on the left here, it's adding these to the illustration as we go along. So very easy to start putting call outs on, but also hotspotting at the same time. Okay, I did mention XCF. So I'm just going to go to File. And we have an option here to export that XCF file, which is basically an XML file. Let's put on the desktop again. And I'm going to leave the name as it is. Just say, I'm going to save it. Just going to off screen navigate to my let's just open that file in Notepad, and then I'll have to bring it back. Oh, there you go. I'll just bring that to the front. So this is the XCF file. You can see the coordinates are down here, the region of where they are. We can see the auto ID that we created. It will align to this. So now I've got something that I could use as a companion file for an illustration. So a slightly different way of doing it. Okay, so let me just move that out of the way. So it's that easy to create that companion file. So what do these files now look, say, within a viewer or in an IETM, an electronic manual? So let's look at the example first, where just bring this over. Whoops. Let me just find that. Okay. So this is the same illustration, but now we've linked it in HTML to the text, and it will work both ways. So if I hover over, you get a tooltip, move over 7, we've got a grommet, we've got a bushing. So as we move around, we've got the tooltip, but it's also going to the table and highlighting that row. And if I click, it should highlight it as well. So I go to number 4, and vice versa, the illustration, we get the hotspotting in the other direction. So this is a CGM file, and this is using our technology VisXView HTML5. So that is a technology where we introduced it because plugins were basically banned by the browser companies. So at that point, a lot of people turned to SVG, but we created this viewer, VisXView HTML5, that can view CGMs without a plugin. So you get the same functionality. You don't have to convert your files. You can keep them as CGMs and still view them. So the quality is excellent. to zoom in a bit further, you'll see it's a really good quality. And that's a CGM in a web page without a plugin. Okay, the other example I wanted to show you here was, just bring up this one, is the companion file. So why would we use that? So in this case, we've got English tooltips. But what if we had a foreign language? So this is now this data is coming from the companion file. So we have now the German part of it. So you wouldn't be able to do this, embed this into a CGM. You'd have to have a companion file to enable you to do this. So now Spanish is the last one. So in this case, the viewer is going to the companion file and bringing back that data from there. Okay, well, finally, we're going to look at something that is actually real. So this is an IETM Eagle Vision from Raytheon. So this is it's just a demo kind of data. This is the S1000D bike. So this is a illustrated parts data module 941A that identifies IPD data modules. And if I click on, say, number 4 here, actually this number 4 has got the same name, so it's highlighting all of them. So there's actually 4 of this particular part on this bike. I can go back. There's a tooltip 001. I move back and I can actually highlight in the opposite direction. So you can go both ways. The same applies. This is just in this case though, this is an SVG, but it originated CGM and then converted to SVG, and now we have all that kind of interactivity still in the file, even though it's an SVG file, and we've authored it in the same way. And this particular viewer, you can zoom in and so forth, so we can get a better view of this. Again, the quality is very good, very good. I'll just finish off by going back to Visit Edit. This is the 2D, and just to show you could actually save as the SVG, which we did see, or the CGM. So either one, you could actually export from here with all that hotspot information. Okay. Let's just briefly go back to the slides. So in summary, 2D illustrations are a critical part of the technical manual and will be for some time. You could add interactivity easily and enhance the end user experience using some of our tools. You could also add interactivity manually, as you witnessed, so or you can actually have them automated. And VisX Edit Plus will automate that in a single file, and then we have another product which we're not showing today called VisX Transform, and that will actually hotspot files in a batch process. So we've actually developed easy to use these solutions and very flexible solutions for hotspotting. We have evaluation versions of all the software you've seen today, so you can go away, request that from us, just email us, and we'll send you a evaluation. You can try it for yourself. So at this point, let's just see if there's any questions. Don't see it. So if you have any questions, please ask them now. I'll just pause a minute. Don, if you want to join me, come back before we end the webinar, just in case we have a question.
Yes, I am here.
Okay. So, yeah, I think just one question we have here about SVG it is now part of the spec. You don't necessarily have to have an SVG authoring tool. You could just use our VisX edit tool, hotspot, and then and save as an SVG. So you don't have to have anything specifically SVG. Okay, so let me, I think that's the end of our questions, to be honest, which is unusual. So I think at that point, I think we'll end the webinar. Thanks for joining us. And there will be a recording available. So if you've missed out on if you want to pass it on to colleagues, we'll make sure you actually get that. Thank you very much for your attention today. We will send the recording out. Thank you.